Lesson 20 is called Rigid Motion on the Coordinate Plane. The objectives are to compare and make generalizations about the coordinates of a transformed image. So this is going to be a lot more about the coordinates and less about what the actual picture looks like when it was reflected, rotated, or translated. Okay, so we start with example 1. It says, use the rule to translate triangle ABC. Write the coordinates, graph the image, and describe the translation. Okay, I know there's a lot of stuff written here underneath. Just ignore all that. It's more just so you can pause the video and write down everything. It's very specific. So just go, we're going to kind of a little bit go out of order here, but it says use the rule to translate ABC. Triangle ABC. Write the coordinates. So the first thing we're going to do is look at triangle ABC and write down the coordinates. So A is at -6, 1. B is at -2, 5, and C is at 1, 2, and we took those right from the coordinate plane. It says use the rule to describe the transformation. So back up here at the very top, this is your rule, and you'll get a lot more familiar with these, but what it says is x comma y. That just means any ordered pair, and then it has an arrow. So the arrow means you're going to do some type of transformation. It says x plus 5, y minus 6, which means you're going to add 5 onto every one of your x values, and you're going to subtract 6 from every one of your y values. Okay, we'll go through and we'll do the x values first. So A prime is right here. That's going to be our new image. Remember, the x value used to be -6. So we're going to take -6 plus 5, and the new x value is going to be at -1. Okay, for B used to be at -2. So B prime, we're going to take -2 plus 5, and B prime, the x value is going to be at 3. And for C, the x value was at 1. We're going to take 1 plus 5 because of the rule up top says x plus 5. And your new x value for C is going to be at 6. Now we'll go through and we'll do all the y values. Again, remember, it says y minus 6. So we're going to take every y value and we're going to subtract 6. So back to A, we had 1. We're going to take 1 minus 6, and our new y value will be at -5. For B, we were at 5, so B prime, we're going to take 5 minus 6, and our new y value will be at -1. For C, we were at 2, so for C prime, we're going to take 2 minus 6, and we will be at -4. Okay, now, those 3 new coordinates, we're going to graph those 3 coordinates. And I don't have this done on the coordinate plane, so I'm going to do it right now. So A prime is going to be at -1, -5. Oops, let me change that to pencil. -1, -5. Okay, that is our new A prime. B prime is going to be at 3, -1. Right here will be B prime, and C prime will be at 6, -4. And then go ahead and connect all the lines, and you have your new image. Okay, so now look at what happened from ABC to A prime, B prime, C prime. It wasn't reflected because B was not flipped upside down, or C. It wasn't rotated because it wasn't turned upside down. It was translated. So if we forget about everything that's over on the left and we just look at the 2 figures, let's figure out how it was translated. Okay, so the first thing, it was moved to this is the original, B is the original, and B prime is the image. So we'll figure out how far it was moved over. It was moved over 1, 2, 3, 4, 5. Okay, so it was moved 5 to the right. Well, that 5 to the right and this x plus 5 means the exact same thing. There's a connection there. Okay, and then it was moved down. So from here, it was moved down 1, 2, 3, 4, 5, 6. It was moved down 6, and that's what y minus 6 means. So it's kind of like it's giving you code up top, and you don't necessarily have to graph the picture. You don't have to write out all the coordinates and graph the picture to figure out that this was a translation 5 right and 6 down. Okay, so we'll go back over to what's written here in pink. First of all, anytime you have these x pluses and x minuses, a rule like this will always mean a translation. And I know this is the first one you've seen, but as you start to see others, you'll be able to recognize, oh, this is a translation. Okay, x plus 5 means add 5 to every x value. Okay, that will move the triangle 5 units to the right. So anytime you have x plus, you will be moving the triangle to the right. However, whatever the number that comes after it. If you have x minus 5, that would be moving the triangle to the left. Y minus 6 means to subtract 6 from each y value. It also means that will move the graph 6 units down. Y minus will always move the triangle or whatever the shape is down. Y plus will always move the triangle up. Okay, so this is just one example. You'll practice a lot more of the translation rules. Example 2 says reflect triangle DEF over the x-axis. Write the coordinates and graph the image. Write a rule. Then reflect over the y-axis. Write the coordinates, graph the image, then write a rule. So in example 1, we started with the rule. That's where you have x comma y in parentheses with the arrow. This time it's telling you do the reflection, write the coordinates, graph it, and then figure out the rule. Okay, so again, there's a lot of writing here, but let's just focus on one thing at a time. So up here we have reflect over the x-axis. Okay, so let's take DEF and let's reflect it over the x-axis. So over the x-axis is going to put F prime right there. E is up at positive 5, so it will be down here at negative 5. And D was at 4. So D will be down here at negative 4. Label this one as D prime. And this one is E prime. Again, if it is a reflection, it should look like it's upside down. Okay, so what we did over here, skip some of the writing. Okay, so D was at 6. Oops. D was at negative 6, 4. And when we write the coordinates for D prime, it's now at negative 6, negative 4. When we write the coordinates for E, we were at negative 1, 5. When we do the reflection for E, we are now at negative 1, negative 5. And F was at negative 2, 1. After we do the reflection, we are at negative 2, negative 1. Now the coordinates are going to help you come up with the rule. So when you reflect something over the x-axis, here's a lot of things that you notice. The x value negative 6 stayed exactly the same. The x value negative 1 stayed exactly the same. The x value of negative 2 stayed exactly the same because we didn't move this triangle left or right at all, and that's how you change the x values. All we did was drop it down below the x-axis. So any of the coordinates, this triangle was up above the x-axis with the positive y values. We reflected it below the x-axis where all the y values are negative. Okay, so what happened was your y value of 4 changed to negative 4. Your y value of 5 changed to negative 5, and your y value of 1 changed to negative 1. So here's the rule. xy, which is any coordinate, just for reflection over the x-axis, the x value will stay the same. So we just represent that as writing an x. Whatever it was before, we write the exact same thing. And the y value will change to the opposite. So we put a negative y in front of that because if it was positive, it becomes negative. If it happened to be negative, it will become positive. Okay, so, and that's written here in words. The triangle will drop straight down. The x values won't change. The y values will become the opposite. So this here in red, this is just one of the rules that you're going to need to memorize or be able to, if you see that rule, you'll know it was a reflection over the x-axis. Okay, let's do reflection over the y-axis. Okay, so we're going to go back to triangle DEF, the original. And what's going to happen though is the triangle will flip to the side, but it's not going to move up and down. Well, your y values are what move up and down. So if it's not going to move up and down, the y values will stay the same because the height doesn't change, but the x values will become the opposite. Okay, let's go ahead and graph what it looks like after you reflect it over the y-axis. So back here to the original, E is going to move over on this side of the y-axis for E prime. F is going to move on this side as well. And D is going to be right here. Okay, so that's our triangle reflected over the y-axis. And then if you write the coordinates, you'll notice it's the same thing over the x-axis, but just slightly different. So your x value for D was at -6. Now it's at +6. But your y value 4 stayed exactly the same. Your x value at E was at -1. Now it's +1. And your y value stayed exactly the same. For F, your x value was at -2, now it's +2, and your y value stayed exactly the same. Okay, so here's your rule down here, I'm highlighting in green, xy, which is any coordinate, if you have a reflection over the y-axis, the x value this time becomes opposite and the y value stays the same. Just a small trick, sometimes it helps you remember these rules with the reflections because they're so close. Whichever axis you are reflecting over, that's the coordinate that stays the same, and the other becomes the opposite. So if you reflect over the x-axis, x stays the same, y becomes the opposite. If you reflect over the y-axis, y stays the same, x becomes the opposite. Now we have example 3. We're going to move on to rotate. So rotate triangle GHJ 180 degrees around the origin. Write the coordinates, graph the image, and write a rule. So you probably know what something looks like when it's turned upside down, but on a coordinate plane you might not know exactly where the coordinates go. So we'll go through and we'll write the coordinates out first. So here's G. G is at 0, 0. If it says rotate it around the origin and G is at the origin, when you rotate it, G won't move. Okay, so over here with our coordinates, G was at 0, 0. G prime is still at 0, 0 because it didn't move. So as far as coming up with a rule, that coordinate does not help you at all because it never moved. But when you rotate, let's do H next. When you rotate H, it's up here at 2, 5. When you rotate something 180 degrees, you're going to end up down here somewhere, but you go through 2 quadrants. So you went over the x-axis at some point, even if you went the other direction, and then you went over the y-axis. So when you go over the x-axis, one of them stays the same, one of them becomes opposite. When you go over the y-axis, one of them stays the same, one of them becomes opposite. Well, because we're going 180 degrees through both the x and the y, what happens here is they both become opposite. So if H was at 2, 5, where it's going to be after you rotate it 180 degrees is at -2, -5. Okay, so it's more over there, H prime. And J, if J was at 6, 3, they're both going to change to opposites. So J prime is going to be at -6, -3. And then you can connect the triangle. So again, we kind of already did that as we were going through the coordinates, but look one more time. H was at 2, 5. H prime would be at -2, -5. J was at 6, 3. J prime would be at -6, -3. And then here's the rule. XY, which is any coordinate, will become -x, -y if you're doing a rotation 180 degrees. Last example here is compare the coordinates of vertices of triangle GHJ of the coordinates of triangles, and that should say G prime, H prime, J prime. It's just double prime, sorry, because we've already moved it once in example 3. Then use the two sets of coordinates to make a generalization about the results of a 90 degrees counterclockwise rotation around the origin. 90 degrees will be the toughest, and it is difficult to make a rule. I'm going to kind of show you another trick that might help 90 degrees just make a little bit more sense. So we're going to look at the two coordinates. If we look at H is right there at 2, 5. And H double prime, which is just the image, is at negative 5, 2. So I wrote these over here so we can look at them closely. Do you notice the numbers that you have? 2, 5 and negative 5, 2. So it wasn't like we went, well, the numbers didn't change. They're just kind of in a different order, and one of them became the opposite. So if you see both opposites, that's rotate 180. If you see one opposite and one the same, that's one of the reflections. Translate is when you're adding or subtracting, so the numbers are changing. So if you see that the numbers are the same and in a different order, right away that should be your clue that it's going to be rotate 90 degrees. Now, what happens here is they switch places and one of them becomes the opposite. But it's difficult to know which one becomes the opposite. So instead of writing out a rule like we were before with the X's and Y's, there are rules, and I will show you on a poster, but sometimes it's easier if you know, if you're starting at H. So let's say we're starting here at H, and it tells us to go counterclockwise. That's this direction. Okay, so what you know, the first thing that happens is they always switch positions. They just flip-flop. So instead of 2, 5, it's going to become 5, 2. And then you just have to ask yourself, look at where H double prime is. Is it possible in that quadrant for the X value to be a positive 5? It's not possible in that quadrant, so the 5 needs to become a negative 5. Is it possible in that quadrant for a Y value to be a positive 2? Yes, and the Y value is a positive 2 in that quadrant. So that's just an easier way to figure out which one is positive and which one is negative. Okay, so let's just say, I know it doesn't say to do on this problem, but if it said rotate clockwise, the first thing that we'd have done is it'd have been somewhere down here. Okay, because we're going clockwise, one coordinate for 90 degrees. And the same thing would happen. Instead of it being 2, 5, it would be 5, 2. But it's somewhere down here in this quadrant. Somewhere. It doesn't matter exactly where it is for right now. But is it possible for the X value in that red quadrant to be a positive 5? Yes, so the X value stays 5. Is it possible for a Y value in that quadrant to be a positive 2? No, because all the Y values in this quadrant are negative. So you have to adjust your coordinate and make the negative on the 2. Okay, so there is a rule, you switch them and then one of them becomes the opposite. But I think for this one, instead of trying to memorize the rules, if you just visualize a coordinate plane and you figure out which quadrant it's going into, you can figure out which one becomes positive and negative after you switch the position. Okay, and last here on the bottom, I just did a recap. These are rules you will need to memorize. You'll put them on a note card and you'll memorize them. So here are the translation rules. You begin with XY. X plus will always mean move to the right. And then it will be followed by a number, and then specifically how many right. X minus will always mean move to the left. Y plus will mean move up. Y minus will mean move down. Or instead of saying move, you should probably say translate instead of move. 2 rules for reflections. If you reflect over the x-axis, here's your rule. You start with xy, and it becomes x negative y, meaning x stays the same, y becomes the opposite. Reflect over the y-axis. Your rule is xy becomes negative xy, which means x becomes the opposite, y stays the same. Again, and then in purple, just a reminder, the axis you go over stays the same. The other one becomes the opposite. And one rule for rotating 180, xy becomes negative x, negative y. They both become the opposites because in order to go 180 degrees, you have to go over both x and y axis. And then there's the rule for 90. And then for rotating any other degree, there's only a set rule for 180 and for 90 either direction.